All right, in this video, we're gonna finally get to what most of this unit is about. We've been spending a lot of time working with exponents and knowing those properties. It all leads up to this. The central idea is what happens when we take exponents and we put them into equations. What happens to them? Okay. So first thing I want to briefly talk about is the difference between what's called linear and exponential. Okay, because algebra is really split into those two main topics. Now, linear, this is what most of Algebra A is about. So for you guys who have been last year's material. So linear, by definition, the way it sounds, linear means line, right? So when you graph these things, it made straight lines, right? The most common equation you guys probably used was y equals mx plus b. And notice in that equation, y equals mx plus b, there are no exponents in there, right? That's one of the key characteristics of what a linear function is. There's no exponents involved, okay? And also by definition, what that means, because it's making a straight line, it means that it grows at a constant speed. Right? It never changes. It always goes by the same amount, okay? So for example, if I were to give you like a function table, which we spent a video back in Unit 1 on this, let's say this was an example of a linear function. So x's and y's inputs and outputs. I'm not going to write the actual equation here, but let's say you plug in 0 and out came 2. Plug in 1, out came 4. Plug in 2, and because we know it's linear, you should see a pattern here. We get 6, and plug in 3, and we get 8. Just to point out a couple things, right? Being that it's linear means it should have a constant growth. Okay, so as x changes, x is changing by 1 each time, right? So plus 1, plus 1, plus 1. So as x increases, the y's should increase by the same amount because it is linear, right? So going from 2 to 4, you're adding 2. Going 4 to 6, you're adding 2. 6 to 8, adding 2. Okay, that's a key characteristic of what it means to be linear. Right? Linear means it's a constant growth. Let's go and write that down below. Constant growth. Okay, now let's take a look at exponential. This is what a good chunk of this class, Algebra B, is about. Okay, so exponential. Okay, well, since it's not linear, it can't be a line, right? So exponential, when we graph these things in a couple videos or so, you will see that these are curves. Okay, so no longer straight lines. Okay, and also by definition, exponential means that you will see exponents. Okay, and a key characteristic of exponential functions is that they grow very fast. Okay, so grow very fast. Okay, so let's do the same thing what we did with linear, right? Linear, we made that table. Okay, so let's make an example of what an exponential table would look like. So let's say we set it up the same exact way. Let's say the inputs are the same exact thing. 0, 1, 2, 3. So the inputs are still increasing by 1 each time, right? Plus 1, plus 1, plus 1. But because it's exponential, we should see that the outputs are growing very fast. So for example, you plug in 0. Again, I'm not writing the actual equation in here, but let's say this was your output values. So 0, 4, 1, 8, 2, 16, and 332. See how it's growing very, very fast compared to like its linear counterpart, right? So, but there is still a pattern to these. And if you go from 4 to 8, you could think of it as adding 4, but that's not going to work for the next one, going from 8 to 16. But it does work if you multiply by 2. Going from 8 to 16, multiply by 2. 16 to 32, multiply by 2. So as you can see, it's growing very, very fast, right? The numbers are getting larger a lot faster, okay? Even though on the inputs, the x's, we did the same thing, the outputs, the y's, got a lot larger, okay? So that's what's referred to as exponential growth. Okay, so that's the difference between linear and exponential, okay? Now let's go ahead and take a look at exactly what these equations look like, okay? I'm gonna go ahead and scroll down. All right, so the general form of an exponential equation looks like this. Let's go write down exponential equation or function. Okay, here's the general format. Y equals a times b to the power of x. Okay, now notice the variable in this equation, the variable is in the exponent position, right? It's ab to the power of x. Okay, if you have a highlighter, I would recommend highlighting this equation. This is the key to what we're doing, okay? Y equals ab to the power of x, okay? Now we're gonna start off slow. The first kind of set of questions we're just gonna ask is, how do you evaluate an exponential equation, okay? So let's start by saying something like this. Oops, let me go back to the pen. Let's say I give you an exponential equation such as y is equal to 2 parentheses 9 power of x. And the question is evaluate for x equals 3. So really this is just saying, like, do you know how to input 3 and see what comes out? Like you're kind of making a function table, right? Plug in 3, tell me what comes out, okay? So the idea is just plug in 3, okay? So 2 parentheses 9, and then where the x is, replace with a 3. Then you have to remember your order of operations, okay? I'm gonna do them off the side over here. Let's see if I can do them right here. So it's parentheses, exponents, multiply and divide, add and subtract. Okay, so it says parentheses first. So look inside the parentheses. We just have a 9. Can't really do anything with that. So then you go on to the next one, E, exponents. We do have an exponent in this case. We actually have to do that first. So we have to take care of this before we can take care of the 2. So 9 to the power of 3, remember that means 9 times 9 times 9. Okay, use a calculator if you need to. Okay, and you get that 9 to the power of 3 is 729. Okay, and again, it's exponential growth, right? So we should be seeing larger numbers because they're growing a lot faster. And then now you can do the deal with that 2. So 729 times 2, again, you can use a calculator, and you end up with the answer of 1,458. Okay, so that's how you evaluate a exponential function. Okay, so you plug it in for x, and then the order of operations. Remember, the exponents have to happen before the multiplication part. Okay, other than that, it's not too bad right now. Okay, let's try one more together, and then we'll be done. Let's say we use the same equation, same function. So still using y equals 2 times 9 power of x. But let me change it up. Let's say the question is evaluate for x equals -2. Okay, because we should be able to plug in negatives as well. The same thing, plug in -2 for x. So 2 times 9, replace the x with a -2. Okay, now here's why we spent so much time working with these exponent properties, is we have a negative exponent in there. So we have to know what to do with that. Okay, remember the rule for negative exponents is they have to switch sides. Okay, but be very careful. The -2 only is being applied to the 9. So only the 9 is going to move. So this is what we end up with. So that 2 is still there, but the 9 is going to move down below. And now it's a +2. Okay, now we can evaluate that, and then we're done. Okay, so 2 is on top, and then 9 squared, remember it's 9 times 9, which gives you 81. Okay, it doesn't reduce, so this would be your answer. Okay, so that's why we spent a good amount of time on the properties. We're making sure you guys knew how to do that. In the next video, we'll talk about how to actually graph these things so you can actually see the curve as far as how these functions look.